We launched in the middle of the night, on a night when we were kind of wondering whether we were going to go fly or not. We finally got to go ahead and suit up. This is my favorite piece of gear to put on. Very, very comfortable. Here's Borneo putting it on his suit for his first flight. You see John Grunsfeld on the right. Everybody's raring to go. We had a sort of a marginal call from the weather guys, for those of you that followed it. Sam on the left and Ron on the right. We're all kind of thinking that this is sort of a dress rehearsal for the real launch day, which would probably be the next day. Tammy putting her suit on, and Wendy. Suit techs did just a marvelous job. I think we may be one of the last flights that actually wears the LES as we get ready to go into the ACES suits. But we were all fired up and ready to go, and lo and behold, we went to fly.
Here we are, starting the main engine 7 seconds before launch. Of course, a little over 1 million pounds of thrust there. 2 SRBs, you see the twang maneuver, Steve in the left window, 2 SRBs lighting, and basically 4.5 million pounds of weight and 8 million pounds of thrust, pushing us upwards. Instant daylight. Obviously, you can see how well we illuminated things. John and Wendy were able to actually see the launch pad, the smoke plume, and the coast by looking back through a mirror. And obviously a majestic sight for everyone as we quickly disappear from sight here. And approximately 2 minutes, we approached the SRB SEP, which of course gave us a beautiful view of the forward rockets as they separated inside. And we were on our way to orbit.
Here we are, a little over an hour into the flight, just witnessing this beautiful view of the Earth. But flight day 1 is extremely busy, and so we needed to get to work. We opened our payload bay doors a little over an hour into the flight. And then soon we'll be activating our Space Lab pallet and activating our instrument pointing system, all of which is done from the aft flight deck. Once we attach our telescopes to the instrument pointing system, we deploy that IPS and instruments to the upright position. And then a little bit later on, we'll be doing a thorough checkout of the IPS and also a checkout of all our ultraviolet telescopes in preparation for the next 15 days of astronomical observations. From the left-hand side, I work the IPS side, and Sam on the right-hand side is doing the instrument checkout.
We were able to very quickly settle into the routine. I was responsible for making sure the orbiter was pointed at the right part of the sky. Tammy was responsible for fine-tuning with the instrument pointing system. And then the telescopes would lock onto the target. And you might be wondering why we're looking at the Earth, but we're currently rolling to the right attitude. The idea was that we would pick up a star as it rose above the Earth's limb, and then Sam would go to work making sure the experiments were ready to start the observation. And quickly, we have the Astro Star Tracker on the left, UIT, HUT is right in the middle, and Whoopi is on the right-hand side. A very, very capable package of telescopes. It really did an outstanding job.
We had a number of tools on board to help us evaluate how we were doing. We communicated to the telescopes primarily through the small laptop computers. I'm issuing commands directly to the telescope, and you saw Tammy issuing commands to the instrument pointing system. This is what we would see through the Hopkins ultraviolet telescope. It had a TV camera that actually looked out through the telescope, and here you see an acquisition of the planet Jupiter. We're actually looking at the space around Jupiter, and displayed below that was a spectrum that we're actually acquiring. Here you see the Wisconsin ultraviolet photopolarimeter experiment in the foreground, and this is the type of image we would get from the Whoopi instrument. This shows a star in the acquisition camera, and in addition we had the spectral data from Whoopi also to evaluate the target to make sure that we were looking at the right target and the data was good.
Well, what ended up being a very, very short checkout period. We got into the routine of observing target after target for for the rest of the mission. John and I were the redshift back end of the bus operators with Borneo in the front, and Borneo would do a maneuver of the orbiter. John would maneuver the IPS to the correct attitude, turn the manual pointing controller over to me after the IPS maneuver was done, and I would do the target acquisition on the CCTV displays, and the telescopes would be set off on their way observing the object. And here again you see the CCTV displays that we had on board to make sure we had the right target.
This information was also available to all the scientists on the ground, and there was a huge team working at Marshall, as well as all the folks here at Mission Control working. And here we see our alternate payload specialist, Scott Jernigan, and we were in regular communication with the APSs and the other folks at Marshall working the telescopes. Every day they'd send us up a few pages of new information on new targets and target procedures, and also all the orbiter procedures and information. And so that was part of our duties on board to incorporate that into the Rolodex. And Tammy helping me out there. That was part of our daily activities. We also had, as I mentioned, the mid-deck active control experiment. And here you see it with the disturbance at the far end on the right there, disturbing the whole structure. And that's free-floating or near free-floating in the mid-deck. And in just a second, you'll see the control take over, and the left-hand gimbal suddenly locks in, even though the right hand is still disturbing. And this was the way it worked most of the time, quite well. Here's a case where the left-hand side is supposed to be pointing inertially in space, but obviously this is a oscillatory divergent case where the control wasn't quite enough. And you wouldn't, if this were a space station, I don't think you'd want to be aboard. And these were fun to watch, but by far the minority. And this was just a great interactive experiment, as you can see by the expression on our commander's face, and Borneo Bill to the left there.
Fortunately, the other mid-deck experiments were rather benign. We just spent most of our time cleaning the filters on the protein crystal growth experiments. You can see John here participating in a medical DSO that was determining the function of the eyes and the head, your gaze on orbit. He's definitely wired for sound in this scene. And again, Dr. Saraks, also known as Ron, talking with one of the many school contacts. We spoke to schools literally around the world, India, South Africa, as well as throughout the United States. That was really, again, as John said, one of the more enjoyable aspects. And of course, we'd had to include Bill on the bike. He had to arm wrestle the rest of us for time, though. He didn't live on the bike. We actually made him work. But as I said before, it was a great way to get some exercise and to relax while you're on orbit.
Well, that exercise is likely to make anybody hungry, and some of us were hungrier than others. As we see, Borneo here was first in line at the galley. Redshift usually had dinner together. We usually had a cocktail hour first where we all had a shrimp cocktail. Here you see a blue shift person coming in here, probably didn't have enough breakfast, trying to get somebody's food away from them. And of course, playing with food, you know, no matter how often your mom told you not to play with your food, it's just impossible not to do that in space. And you see Tammy here with fluid physics experiment, some tropical punch floating free in the mid-deck, which she was able to vacuum up post-haste. And of course, we don't have a shower on board, and that's the best you can do.
Earth observations, as we said, was one of the more enjoyable things to do, and also an important part of the shuttle program. And here is Wendy's famous Barren Island volcano in the Andaman Islands. And that was neat to look for that kind of stuff. That was a great discovery for us to be able to report that to the ground. Again, Shark Bay, this is a larger view of it. And from day to day, we could see variations, both due to tidal differences and also from the rain in Australia. This is looking towards the south. Up at the very left end of the picture is Adelaide and some of the dry lakes in the Ayr Lake region. And some of these also had water in them. And we had both color visible film and infrared film, and we took sometimes pairs of pictures of the same region. We also had an opportunity on a number of passes to see the Hawaiian Islands. Tammy showed you the Oahu view. Here's the big island of Hawaii. And on the top of the picture there on the volcano are a number of NASA observatories that also do astronomy. And we really enjoyed taking the pictures.
This is another beautiful view of a sunset on orbit. It takes about 90 minutes to orbit the Earth, and so one gets to see a sunrise or sunset every 45 minutes. And this is one of the storms that we witnessed in the south central United States. You're looking north is at the top of the screen. To the left, you can see Louisiana, all the way up to Atlanta, actually. And on the right-hand side, of course, is Florida. And it's a very graphic depiction of city lights and storm activity.
Eventually, we have to come back home. This is a graphic visualization of the pilot DTO. You can see an actual approach here on the computer screen, working with the controller, which is mounted to the existing stick on the orbiter. In addition to that, prior to coming home, we went ahead and did a check on the flight control systems. And what we do is we do a check of all the jets and also the flight control surfaces to make sure that the orbiter does perform as advertised. And here, the three orbiter folks, Steve, Wendy, and myself, are going through the flight control system checkout, and you'll now see the Elevon moving in the background. And you can really feel this just shake the vehicle as it slams back and forth against the hard stops.
And then the final step before we come home is to turn the orbiting observatory back into a flying machine. And it gets kind of hectic there when we're trying to pack everything away and then put our launch and entry suits back on and get ready to re-enter. Here you see Ron and I, and our Suits Are Us logo there, putting Borneo in his suit. Once that's done, then just before we deorbit, we close the payload bay doors and seal the payload bay so that we can re-enter the Earth's atmosphere.
As you're probably aware, we were originally scheduled to land at Kennedy Space Center on the 17th of March, which would have been 15.5 days on orbit. Unfortunately, the weather in Florida didn't accommodate that landing, so we put the telescope away. Never did actually close the doors. The Mission Control Center folks never put us into the suits because the weather was so bad. They didn't think that we had a chance at it. The next day, Saturday the 18th, we made one look at the Kennedy Space Center, waved off on the first rev, and went ahead and burned to Edwards Air Force Base on the second deorbit opportunity on the 18th. There you can see the hack. We're on final now into runway 22 at Edwards. And the winds were a little bit gusty at Edwards. You can see a little bit of the dust coming off of the lake beds, but there wasn't an appreciable amount of turbulence. We could feel a little bit of turbulence on final, and the right to left crosswind was definitely noticeable, but nothing that wasn't well within the performance capabilities of the orbiter. And for those of us that have flown before, there wasn't a whole heck of a lot of difference between an 8-day to 10-day flight and a 17-day flight. So if there is a limit on the amount of time that people can go to space and come back and land an orbiter, we don't think it's at the 17-day point. It was a wonderful flight. We had an orbiter that gave us virtually no problems whatsoever. The folks down at Kennedy Space Center should be very, very proud of the orbiter that they gave us. We hope that we gave it back in pretty good shape to them so that they can turn it around for the next bunch of folks that go fly it. It was a tremendous adventure for us. We were very pleased with the results. I had a tremendous group of people to go fly with, exceptionally talented group of folks.
Some clip of the activities of STS-71.
Other guys, for those of you that followed it, Sam on the left and Ron on the right, we're all kind of thinking that this is sort of a dress rehearsal for the real launch day, which would probably be the next day. Tammy putting her suit on, and Wendy. Suit techs did just a marvelous job. I think we may be one of the last flights that actually wears the LES as we get ready to go into the ACES suits. But we were all fired up and ready to go, and lo and behold, we went to fly.
Here we are, starting the main engine 7 seconds before launch.
Activating our Space Lab pallet and activating our instrument pointing system, all of which is done from the aft flight deck. Once we attach our telescopes to the instrument pointing system, we deploy that IPS and instruments to the upright position. And then a little bit later on, we'll be doing a thorough checkout of the IPS and also a checkout of all our ultraviolet telescopes in preparation for the next 15 days of astronomical observations.
Approximately 2 minutes, we approached the SRB SEP, which of course gave us a beautiful view of the forward rockets as they separated inside, and we were on our way to orbit.
Here we are, a little over an hour into the flight, just witnessing this beautiful view of the Earth. But Flight Day 1 is extremely busy, and so we needed to get to work. We opened our payload bay doors a little over an hour into the flight, and then soon we'll be active.
We launched in the middle of the night, on a night when we were kind of wondering whether we were going to go fly or not. We finally got to go ahead and suit up. This is my favorite piece of gear to put on. Very, very comfortable. Here's Borneo putting on his suit for his first flight. You see John Grunsfeld on the right. Everybody's raring to go. We had a sort of a marginal call from the weather.
Of course, a little over 1 million pounds of thrust there. 2 SRBs, you see the twang maneuver, Steve in the left window, 2 SRBs lighting, and basically 4.5 million pounds of weight and 8 million pounds of thrust, pushing us upwards. Instant daylight. Obviously, you can see how well we illuminated things. John and Wendy were able to actually see the launch pad, the smoke plume, and the coast by looking back through a mirror. And obviously a majestic sight for everyone as we quickly disappear from sight here. And